Good morning, students. Today we have a very important question from board point of view. That is, you need to prove that square root of n plus 1 plus square root of n minus 1 is an irrational number where n is any positive integer. So to prove this one, before going to the method how to prove, let us take an example that this one is your irrational or not. You can take any value of n. You must take positive integer. I am taking n equal to 3 here. If you put n equal to 3 here, then you have square root of 3 plus 1, that is 4. Square root of 4 is 2. So you have 2 here in the first term. And if you put 3 here, then you have 3 minus 1, that is 2 square root of 2. So that is 2 plus root 2, and you know that that one is irrational. You have done many questions like that. And also, if you put n equal to 5, if then you have 5 plus 1, that is 6. Square root of 6 will be here, and if you put 5 here, then you have square root of 5 minus 1, that is 4, and that give value 2, means root 6 plus 2. And you can imagine that one is also an irrational number. So you can take many examples like this in your mind, but we will not prove this by any example. We will prove by our traditional method, as we are doing many questions with that. Since it is uh, we need to prove that this one is irrational. So what we will do, on contrary basis, we will suppose this one as rational. That is the only way to prove this one. And if we are supposing this one as rational, then we will say that this will be in the form of p upon q, and q is not equal to 0. So we are taking any value n for which this one is rational. So let us suppose there exists a positive integer n for which this relation square root of n plus 1 plus square root n minus 1 is a rational number. So if it is rational, then we can say that this will be equal to p upon q, where p and q are positive integers and q is not equal to 0. Make a correction here, this is not equal to. Okay. So to prove this one, we have this one, and also make in your notebook that this one is your equation A. So mark this one as your equation capital A, since you will take this one as capital A. And what we'll do the reciprocal of this one. Here I'm having some space, so you will write here that this one is equation A, and doing reciprocal of equation A, then you will have q upon p is equal to 1 by this one. So you have 1 by n minus 1 plus square root n plus 1. So we have something here in roots. In the denominator part we have root, and we already studied in class 9th. We have, if we have root in denominator part, to make this one as a simplest way, we will rationalize by changing the sign of these two terms. So we'll multiply this one by square root of n minus 1 minus square root of n plus 1. So in denominator part, you will always have a term like a plus b and a minus b. That will be always a square minus b square. So square of this one and minus square of this one we have in denominator part always, and we have numerator part as the sign change of this one, that is square root of n minus 1 minus square root of n plus 1. So this n will be cancelled out when you open the brackets, and this will be minus 1 and minus 1. This will be minus 2 here. To avoid this negative sign, what you will do, you will take negative common from the numerator part, and when you take the negative common, then this square root of n plus 1 will become positive and this will become negative, and will this 2 will come on your left hand side, that will come in multiply, this will become 2q upon p, and that will be equal to this n plus 1 come on the first part, this will become positive and n minus 1 will become negative due to this one. So I already told you that you mark this one as equation A and mark this one as equation number B. So mark this one as equation B. So our motive is to add these two equations, and then we will do the subtraction of these two equations in the second part. So when you add these two equations, when right here that adding equation A and B, then you have square root of n minus 1 plus square root of n plus 1 plus square root of n plus 1 minus square root of n plus 1, that will be equal to nothing but it is p by q plus 2q by p. And here you can see that this is positive and this one is negative, both are same, you can cancel out these two and you have now 2 times of square root n plus 1. And in right hand side you can take the LCM of these two, you have LCM as pq, so you have p square plus 2q square here, and this 2 will come on the right hand side and it will come in divide. So you have in the last equation, last part, you have square root of n plus 1 equal to p square plus q 2q square upon 2pq. So mark this one as equation 1, and after that what you will do, you will subtract equation A and B. Again I am telling you A and B, you have already marked A and B there, and this one is your A and this was is your B, and in the first part you add these two and in the second part you will subtract the above equations A and B. When you do the subtraction of these two equations, you can easily see this n plus 1 will cancel out, this one is positive, this one is negative, and this will become 2 times of square root n minus 1. And in the right hand side again you can take LCM pq there, and this will be equal to p square minus q 2q square upon pq, and this 2 will come on this side. So we done many more questions like that, and we already know that p and q are integers, and subtraction of these square of these two integers upon the multiplication of these two always rational number. So what we are telling, this right part is rational, and also in equation 1 we have this right part, that is also in 1 you have also the rational number. So from 1 and 2 you can easily say that square root of n plus 1 and square root of n minus 1 are rational number. I have given you the region here. These p and q are integers, and p square plus 2q square upon 2pq and p square minus 2q square upon 2pq are rationals here. So you are taking these two as rationals and these are giving some values there. So n plus 1 and n minus 1 are perfect squares of the positive integers. So these two must be the perfect squares of the positive integers, and we will be having the difference of these two numbers as 2. If we subtract n plus 1 and do minus of n minus 1, then n will be cancelled out, we have 2 here. So which is not possible since any two perfect squares differ by at least 3. I am giving you the example why I am telling you this one, it is not possible. So you can take values that we have least positive integers 1 and 2. If we do the square of 1, then you will have 1, and if you do the square of 2, then you will have 4. And if you subtract the square of these two, it means 4 minus 1, that will be equal to 3, at least 3. It means if you having the smallest numbers, positive numbers, then the difference of the squares always is greater than 3 or 3. You can take any other example. If you have 5 and 6, so 5 square is 25, 6 square is 36, and you have the difference of the squares is 36 minus 25, that is 11, that is much larger than 3. So here we are having the difference of the squares as 2, that is not possible for the value of n when where n is your positive integers. So our assumption is false because there is no positive value integer n for which this one is rational. So our assumption is false. So you can say that square root of n plus 1 plus square root of n minus 1 is always a rational number for any positive integer n. So you have to note it down, this question, and that is very important question from board point of view for the standard. And also you will have an assignment today to try to solve those questions and send me on WhatsApp what you have done. Be safe, stay home.